This is the screencast for Co4d, and part A says a small car exits an expressway on a section of a circularly shaped ramp that is banked at an angle 21.5 degrees. The ramp has a radius of curvature of r equals 49.7 meters. Suppose that the ramp is completely covered in ice, so friction is negligible. If the mass of the car and driver is 1,550 kilograms, what constant speed must the driver maintain in order for the center of mass of the car to stay in the center of the ramp? So from this, we know that it's banked at 21.5 degrees. The radius is 49.7 meters. There's no friction, and the mass is 1,550 kilograms. So we're looking for velocity. So what I did here was drew a picture of our circularly shaped ramp, and the car would go about right here. And next I drew a free body diagram of a car on the ramp that's banked. So this is going to be your force normal, and then you're going to draw components. And this is going to be your force of gravity, which is mg. And if you plug in the values for that, you're going to get 1,550 times 9.8, which leaves you with 15,190 newtons. So this is our free body diagram for the car. So what we're going to do now is do the sum of the forces. So to find velocity, we're going to do the sum of the forces. So sum of the forces in the x direction equals mass times acceleration. So because of this component right here, we have this in the x direction, we're going to have mg sine theta equals m times centripetal acceleration. Therefore, the m's will cancel, and we're left with g sine theta equals v squared over r. V squared over r is how to find centripetal acceleration. So now we're going to bring r over to the other side so we can solve for v squared, and we're going to have g sine theta times r equals v squared, and when we plugged our values in, we're going to have 9.8 times the sine of 21.5 degrees times 49.7 equals v squared. So when you do all the calculations, you're going to have v squared equals 178.5, and then you're going to do the square root of both sides, and you're going to be left with v equals 13.36 meters per second.